The described air conditioner installation is incorrect and presents a potential safety hazard. Using 12/3 with ground cable in the manner described, where the white conductor, typically designated as neutral, is connected as such and the bare copper wire serves as the equipment ground, violates the National Electrical Code, also known as NEC. The proper wiring configuration for a 220-volt air conditioner, according to NEC standards, mandates the use of a 12/2 with ground cable. In this configuration, the white conductor is designated for neutral use, the black conductor serves as the hot conductor, and the bare copper wire acts as the dedicated equipment ground. Crucially, the neutral conductor should never be interconnected with the equipment ground. The rationale behind this separation stems from their distinct functions. The neutral conductor is designed to carry current during normal operation, while the equipment ground is solely intended for safety purposes, providing a path for fault current to flow back to the source in the event of an electrical fault, thus tripping a breaker and preventing electrical shock. Interconnecting the neutral and equipment ground creates a potentially hazardous scenario. This interconnection can result in current flowing through the equipment ground, elevating the risk of electrical shock or even electrical fires. In the specific installation you encountered, removing the white conductor is essential for safety. This involves disconnecting the white conductor from both the neutral terminal in the panel and the equipment ground at the air conditioner unit. Following the removal of the white conductor, the air conditioner should be rewired, utilizing the black conductor as the hot conductor and the bare copper wire as the designated equipment ground. Furthermore, ensuring that the neutral and equipment ground are properly bonded within the service disconnect located outside is critical. This bonding establishes that both the neutral and equipment ground are at the same electrical potential, a fundamental requirement for the safe and effective operation of the electrical system. The NEC provides detailed guidelines regarding grounding and bonding practices to ensure electrical safety. Correct grounding and bonding are essential for minimizing the risk of electrical shock, fire, and equipment damage. The general requirements for grounding and bonding are covered in NEC Article 250. This article provides detailed requirements for grounding electrode systems, grounding conductors, and bonding conductors. Grounding electrode systems must be installed per NEC sections 250.50 through 250.60. These sections specify the types of grounding electrodes that are permitted, such as metal underground water pipes, ground rings, rod and pipe electrodes, and plate electrodes. The grounding electrode system must be effectively connected to the earth to provide a low impedance path for fault current. Grounding conductors are used to connect the equipment grounding system to the grounding electrode system. The size of the grounding conductor is determined by NEC Table 250.122 based on the size of the overcurrent protective device protecting the circuit. Bonding conductors are used to connect non-current carrying metal parts of equipment together to create an effective ground fault current path. The size of the bonding conductor is determined by NEC Table 250.102 based on the size of the largest ungrounded conductor in the circuit. In addition to the general requirements for grounding and bonding, the NEC also provides specific requirements for grounding and bonding different types of equipment. For example, NEC Section 250.146 provides requirements for grounding receptacles, and NEC Section 250.148 provides requirements for grounding lighting fixtures. It is important to consult the NEC for specific requirements for grounding and bonding the equipment you are working with. Improper grounding and bonding can create a dangerous situation, increasing the risk of electrical shock, fire, and equipment damage. Therefore, it is essential to follow the NEC requirements for grounding and bonding to ensure electrical safety. Here's a more detailed breakdown of the key aspects of the situation and relevant NEC considerations. Firstly, conductor identification. The NEC mandates specific color codes for conductors to ensure proper identification and prevent confusion during wiring. The white or grey wire is designated as the neutral conductor. The bare or green wire is reserved for the equipment grounding conductor. Using the white wire as a current-carrying conductor other than neutral in a 220-volt circuit without proper re-identification is a violation. Secondly, grounding and bonding. Grounding refers to connecting the electrical system to the earth, providing a reference point for voltage and a path for fault current. Bonding involves connecting non-current carrying metal parts to create a low impedance path for fault current. Proper grounding and bonding are essential for safety. Thirdly, equipment grounding conductor. The equipment grounding conductor, which is the bare copper wire in this case, provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. It should be connected to the equipment grounding terminal in the panel and the equipment grounding point and the air conditioner. Fourthly, neutral conductor. The neutral conductor carries the unbalanced current back to the source in a single-phase circuit. It should be insulated and kept separate from the equipment grounding conductor, except at the service entrance or separately derived system. Fifthly, 220-volt circuit wiring. A typical 220-volt circuit for an air conditioner uses two hot wires, a neutral wire, and an equipment grounding wire. Using 12/2 with ground cable is the correct way to wire this circuit, with the two hot wires connected to the two poles of the breaker, the neutral wire connected to the neutral busbar in the panel, and the equipment grounding wire connected to the equipment grounding busbar. Sixthly, NEC violation. Connecting the neutral wire to the equipment ground at the air conditioner creates a parallel path for neutral current, which can lead to current flowing through the equipment grounding conductor. This is a violation of the NEC and can create a shock hazard. Seventhly, correcting the wiring. To correct the wiring, disconnect the white wire from the equipment ground at the air conditioner. Connect the white wire to the neutral busbar in the panel. Ensure that the equipment grounding conductor is properly connected to the equipment grounding terminal in the panel and the equipment grounding point in the air conditioner. Eighthly, safety precautions. Before working on any electrical circuit, always turn off the power at the breaker. Use a voltage tester to verify that the circuit is energized. Wear appropriate personal protective equipment, such as safety glasses and gloves. Ninthly, local codes and regulations. In addition to the NEC, local codes and regulations may also apply. It is important to check with your local building department or electrical inspector to ensure that your wiring is compliant. Tenthly, professional assistance. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the work. Electricity can be dangerous, and improper wiring can lead to electrical shock, fire, or equipment damage. Consider the following points for clarification and further guidance. Firstly, the NEC Article 250 addresses grounding and bonding requirements, including the separation of neutral and grounding conductors. Secondly, improper wiring configurations, such as bonding neutral and ground at the load, can lead to stray voltage and increase the risk of electrical shock. Thirdly, the equipment grounding conductor, the bare copper wire, should be connected to the metal frame of the air conditioner and back to the grounding bus in the electrical panel. This provides a low impedance path for fault current to return to the source, tripping the breaker and protecting against electrical shock. Fourthly, the neutral conductor should only be connected to the neutral bus in the electrical panel and should never be connected to the equipment grounding conductor at the air conditioner. Fifthly, using 12/3 with ground cable for a 220-volt air conditioner is not incorrect in itself, but the way it was wired in this case is problematic. The third conductor, typically white, should have been re-identified as a hot conductor using black or red tape and used as the second hot leg of the 220-volt circuit. Sixthly, by disconnecting the white conductor from the neutral in the panel and the equipment ground at the air conditioner, you are eliminating the parallel neutral path and the potential for current to flow through the equipment grounding conductor. Seventhly, it is essential to ensure that the grounding system is properly installed and maintained. This includes verifying that all grounding connections are tight and corrosion-free. Eighthly, if there are any doubts or concerns about the wiring, it is always best to consult with a qualified electrician to ensure that the work is done safely and correctly. Ninthly, using a multimeter to check the voltage between the neutral and ground conductors at the air conditioner can help identify potential problems. A properly wired system should have a voltage of 0 volts between the neutral and ground conductors. 10thly, remember that electrical work can be dangerous, and it is important to take all necessary safety precautions to protect yourself from electrical shock. Furthermore, let's elaborate on several crucial aspects. Firstly, NEC Article 250. This article comprehensively covers grounding and bonding requirements. It emphasizes the separation of neutral and grounding conductors to prevent hazardous current flow. Secondly, stray voltage. Bonding the neutral and ground to the load creates a potential for stray voltage. This increases the risk of electrical shock and can interfere with the proper operation of sensitive electronic equipment. Thirdly, equipment grounding conductor function. The equipment grounding conductor provides a low impedance path for fault current to return to the source. This quick return is essential for tripping the breaker and protecting against electrical shock. It must be securely connected to the metal frame of the air conditioner and the grounding bus in the electrical panel. Fourthly, neutral conductor isolation. The neutral conductor must remain isolated from the equipment grounding conductor at the air conditioner. It should only be connected to the neutral bus in the electrical panel. Fifthly, wire usage and re-identification. While 12/3 with ground cable isn't inherently wrong for a 220-volt circuit, its miswiring is the problem. The white conductor can be re-identified with black or red tape to serve as the second hot leg. This prevents confusion and ensures proper circuit function. Sixthly, corrective actions. Disconnecting the white conductor eliminates the parallel neutral path. This removes the potential for dangerous current flow through the equipment grounding conductor. Seventhly, grounding system maintenance. A properly installed and maintained grounding system is vital. Regular inspections of grounding connections ensure tightness and prevent corrosion. Eighthly, professional consultation. When in doubt, always seek the expertise of a qualified electrician. Electrical work demands precision and adherence to safety standards. Ninthly, voltage testing. Use a multimeter to check voltage between neutral and ground. A reading of 0 volts indicates a correctly wired system. 10thly, prioritizing safety. Electrical work involves inherent risks. Take all necessary precautions to safeguard against electrical shock. Additional considerations include firstly, the importance of proper overcurrent protection, ensuring that the circuit breaker or fuse is correctly sized for the air conditioner's amperage rating. Secondly, regularly inspecting the wiring and connections for any signs of damage such as frayed insulation or loose terminals. Thirdly, considering the use of a ground fault circuit interrupter, also known as GSCI, breaker to provide additional protection against electrical shock, especially in damp or wet locations. Fourthly, consulting the air conditioner's installation manual for specific wiring instructions and recommendations. Fifthly, keeping a detailed record of all electrical work performed, including wiring diagrams and component specifications. Sixthly, ensuring that all electrical work is performed in accordance with applicable building codes and regulations. Seventhly, understanding the difference between grounding and bonding and the importance of both for electrical safety. Eighthly, never overloading electrical circuits or extension cords, as this can create a fire hazard. Ninthly, educating yourself and others about electrical safety practices to prevent accidents and injuries. Tenthly, being aware of the potential hazards of working with electricity and taking all necessary precautions to minimize the risks. Let's further clarify the key points. Firstly, overcurrent protection. The circuit breaker or fuse must match the air conditioner's amperage to prevent overloads and potential fires. Secondly, regular inspections. Check wiring for damage like frayed insulation or loose connections. Address issues promptly to maintain safety. Thirdly, GFCI breakers. GFCI breakers offer enhanced shock protection, especially in damp environments. Consider them for added safety. Fourthly, installation manuals. Consult the air conditioner's manual for specific wiring guidelines and recommendations. Fifthly, detailed records. Keep records of all electrical work performed, including diagrams and component details. Sixthly, building code compliance. Ensure all electrical work adheres to local building codes and regulations. Seventhly, grounding versus bonding. Understand the distinction between grounding and bonding for comprehensive electrical safety. Eighthly, avoid overloading. Never overload circuits or extension cords, as this poses a fire risk. Ninthly, electrical safety education. Educate yourself and others about electrical safety practices to prevent accidents. Tenthly, risk awareness. Recognize the hazards of electrical work and take all necessary precautions. The NEC provides very specific guidance, and understanding it is important.